This is video 5 in the series building my own tiny tabletop precision hydraulic press. In this video, I finish the construction of the double hand pump and do the first tests with this tiny press. There are 2 plungers, so I need 4 valves, for each plunger a low and a high pressure. The only difference between the 2 types is the strength of the compression spring. Here I make a piece of all-thread M8 with a pitch of 0.5 mm. The 4 valves that I am going to make are screwed into 2 continuous channels of the pump. Using an end mill, I make the recess in the valves for the 4 end stops. And here I make the end stops, which hold the compression spring in the valve. With a scale, I look for compression springs that exert just enough force to press the bearing balls properly into the valve seat. In the past, I made these valve seats by scraping them out neatly with a special tool. But afterwards, I found that a firm tap on the hardened ball was enough to leave a nice smooth seat in the soft steel of the valve body. Now, it is time to dig the oil tank out of the steel. Drilling is an operation with cheap tools and fast machining, so I do most of the digging with that. With a carbide rough milling cutter, I do the finishing operations. From some scrap aluminium, I make the lid of the tank. Later, it will be glued into the tank. Now the channels in the pump have to be drilled. Later, the open ends of these channels are closed with a screw-in plug. Here I am working on the two continuous channels into which the fine threads for the valves are cut. Here, the openings from the cylinder bottoms to the channels for the valves are made. Behind the outgoing valves, both outlets are already connected here, and the hole for the screw plug is drilled and tapped. Now the joint outlet must be led upwards, where the outlet to the high pressure hose can be drilled. And here too, a threaded plug closes the channel on one side. This will be the connection to the high pressure hose. Tapered NPT thread for a reliable seal. This elbow connects the digital pressure gauge to the outlet of the pump housing. This cap and pin combination has multiple functions. It closes the filler neck of the tank, is also the breather valve, is the dipstick for the oil level, and at the end there is a very small but strong magnet to remove the steel particles from the oil that are created by wear. All parts are ready. Time for assembly. This is a tricky stage. The valves must be screwed into their channels and then mounted leak-free with metal glue. The correct position and amount of glue are crucial. A mistake here can not only cause incorrect operation of the pump, but is also extremely difficult to fix. I start with the inlet valves, which I can access for gluing via the open oil tank. The assembly of the outlet valves is even more difficult. Only through the channel that connects them both, I can carefully apply the metal glue. In a possible next design, I will do this part differently. Insert plugs into the ends of the valve channels. This is the pressure relief plug. More on this in a minute. The end of the connection between the output channels is used to connect the pressure gauge via an elbow. The pressure relief valve allows the oil to flow back from the outlet into the tank once opened. The drilling of the long 2 mm hole to the tank was done off camera. The vertical channel to the outlet and the pressure relief valve is closed off at the top with a plug. Off camera, I made the grooves for the O-rings of both plungers with a 1.5 mm wide parting plate. Okay, the pump build is done. Let's fill it up and test it. Oops, a leaking pressure relief valve. Probably because of a slightly too narrow waist, but that's not the only mistake I made. I also forgot to mill a channel for the oil. Now, it has to be pressed to the tank via the M5 thread, which of course goes much too slowly. Over 4 metric tons of press force in such a small machine. Great. And I could go even higher, but I haven't designed the machine for that, so I'll leave it at that. But I still see that the pressure drops. Not as fast, but still not acceptable. The source is quickly found. Apparently, the sealing ring between the piston and the cylinder wall is not closing properly. Fortunately, the pressure release valve is working fine now. The pressure drops very quickly when I open it. I also notice a mismatch between force and pressure. With 16 square centimeters of cylinder surface, 256 bar should result in a maximum of 4,100 instead of over 4,300 kilograms of force. Next video, I hope to have solved these issues and to neatly complete the fit and finish of this machine. Then I will make some attachments and we can do some interesting tests. Hope to see you then.